All right, in this video, we're going to go over Chapter 9, reviewing for the final. Here's some of the topics you might see on the final for Chapter 9. And just a reminder too, during this video, have out pencil paper, try the questions before watching the solutions, right? If you just watch the video, not going to be as helpful as trying to remember how to do the questions. Big thing for Chapter 9, there was a lot of formulas in this chapter. So there's this formula sheet. I can't even fit it all on the screen here, but you can find this out on our Schoology page in the review folder. And then also this will be given to you on the final exam. So you don't have to memorize the formulas, but you just have to know, the difference between arithmetic and geometric. Arithmetic's add, subtract, geometric's a multiply or divide pattern. And then you have like explicit formulas that can be used to like find the 10th term or the 100th term. And then if you have to add up all the terms in a sequence, that's called a series. And then there's these different formulas for finding the sum of the series depending on if it's arithmetic or geometric, and then if it's finite or infinite. And remember, infinite are sequences that just go on and on forever. All right, so first question here, list the first 5 terms of this sequence. Okay, so here's the little formula. Okay, and remember the two things we have are n, the position, and an, the value. So the first 5 would just be n, 1, 2, 3, 4, 5. All right, and so pause the video and see if you can find the values. All right, so the way you do this is you just plug it in, kind of like x and y. You just plug in 1 for n, so you'd have 5 plus 8. So an is 13, and then you put 2 in for n, so you'd have 5 times 2, 10 plus 8 is 18. And you can start to see that this is actually kind of our slope, so it's just going up by 5 each time. So you can keep plugging them in if you want, but essentially you're just going to get a plus 5. And then we could do a dot, dot, dot. So it says, what is the 20th term? So that's like an n of 20. 20 is the position. So plug it in the formula, and we'd say a sub 20, the value at the 20th position is 5 times 20 plus 8. So that's 100 plus 8, 108. So we could write like n of 20 gives us an an of 108, a value of 108. So we could like continue our table out and say the 20th position is 108. And that's kind of the handy part of these as an explicit formula, is you can just plug it in and find any position. Okay, so next up is writing this formula is really an important skill. So the formula, if you look on the formula sheet, is there's 2, one for geometric, one for arithmetic. I believe this is an arithmetic pattern, so the arithmetic pattern formula looks like this. So see if you can remember how to use that formula. All right, so an and n are going to be our variables like x and y. So we're going to say an equals the first term, which is 8. And then d stands for the common difference. So here we're going down by 3. So d is negative 3. Okay, and that's a fine formula. Oftentimes they'll actually clean it up. So it'll distribute this negative 3 and then clean it up. So you have 8 plus negative 3n plus 3. And you don't have to do these steps, but traditionally that's what you're going to do. So 8 plus 3 is 11. So you have like 11 minus 3n, or sometimes they'll write like negative 3n plus 11, however you want to write it. But that's the explicit formula for that sequence. And I guess before we move on, the value of this explicit formula is you can find any term. So we have the first 4 terms, but if we want to find the value for, let's say, the 100th term, all we got to do is put in 100 for n. So a sub 100 would be negative 3 times 100 plus 11. So it'd be like negative 300, sorry, that's a bad looking 11, plus 11 would be negative 289. So the value at this 100 spot would be negative 289. And again, that's kind of the cool part about an explicit formula, is you can find any position. Okay, so slightly different question here. So this is explicit formula. Well, I don't know why and. Find an explicit formula for the sequence. Right, so basically this one's going to be the geometric type. So in geometric, you multiply by a value n minus 1 times. So see if you can fill in the rest of this pattern. not pattern, sorry, the formula. Okay, so we're going to say an is equal to the first term 3 times r is just what you multiply by each time. So on this one, I think we're multiplying by 5. So times 5 n minus 1 times, right? And that's the formula. So that we could find, again, any position. So if we wanted to find like the 10th spot, a sub 10 would be 3 times 5 to the 10 minus 1 power, or 3 times 5 to the 9th, and then just do 5 to the 9th first times 3. All right, so we get almost 6 million, which is not too surprising. I mean, the number starts small, but when you multiply by 5, it's going to go up really fast. So that would represent the 10th term. Okay, so find the 100th term of the sequence. See if you can pause the video and figure this out. Okay, so we really want to find the 100th spot, and that's an n. All right, so basically first term is -5, second term is -1, third term is 3. So what we want to do is do the formula, right? Do the explicit formula and then use that to find the 100th spot. So first thing is we got to know that this one's arithmetic. We're going +4 each time. So our pattern or our formula is an equals a1 plus dn minus 1. All right, and so then a1 is just the -5, d is 4, because we're going up by that each time. And again, you don't have to clean this formula up, but I'm just going to do it just, I don't know, just because that's normally how it works. Not sure why I'm so stuck on having to do that. But anyways, distribute the 4 and then combine the -5 and -4. Okay, so now for the 100th term, which they're going to call like a sub 100, the value at the 100th spot, we're going to do -9 times, sorry, +4 times n of 100. I'm just putting 100 right there. Okay, and now we just do -9 plus 400, and so that's going to be 391. So the 100th spot would be 391. So there you got to write the explicit formula first, and you're going to do that a lot, right? Writing that explicit formula is super important for chapter 9. Okay, so now we're going to try to find the sum. So we're going to add all these up. And so again, there's going to be a formula from that formula sheet. So to make some sense of which formula to use, you got to figure out, is it geometric or arithmetic, and then use the one that talks about finding the sum. So forget if I loaded the formula sheet here, but you can look back, I guess. You can look back. So you got to figure out which of these formulas you're going to do, right? Is it arithmetic, geometric, and then which formula is it, like finite, infinite? So pause the video and try this one. Okay, first thing is this is arithmetic because we're going +2, all right? And so the arithmetic formula looks like this. It says the sum of n terms is the number of terms divided by 2, first term plus last term. So to find the sum here, we know the first term is 27, we know the last term is 47, but what we don't know is how many terms n, right? So basically, we know this is the first term, second term, third term, but what term is this? Is it the 10th, the 11th, 12th? We're not really sure. And you could kind of try to figure it out, right, using the fact that we go up by 2. But I guess to be absolute sure, I'm going to do my explicit formula and then use that to figure out what position we're at there. So explicit formula here would be a1 plus 2 is the common difference, n minus 1, and then clean it up. It'd be 27 plus 2n minus 2, and then positive 27, -2 is 25. Okay, and then this is a tricky part where we're going to plug in for either an or n, but we've got to figure out, is 47 an an or an n, right? And so the trick is these numbers up top are the positions, and these numbers are the values. So that means 47 is a value, so it goes here. We want to find its position n. So if we plug it in for the value and then solve for n, So we're going to minus 25 from both sides. So we get 22 equals 2n, and then divide by 2 and get 11. So 47 is in the 11th position. Okay, and so that, to finally finish it, that allows us to find the sum because that means there's 11 terms in our sum. So to do the sum, 11 divided by 2 is 5.5. 27 plus 47 would be 77, and then multiplies those together to get our sum. So it's actually kind of interesting. So I did this on my calculator and I got 423.5, but that doesn't make any sense because none of these numbers in my sum are decimals. So then I was like, I must have messed up somewhere, right? And so I think what I did is 27 and 47. I think that should be 74, not 77. So 74, and then see if my answer makes sense now. Now I get 407, so that seems to make a little more sense. So the sum should be, I think, 407. Okay, so summation notation, basically how it works is you got this big E, and it's a way to condense a big long sum. So here I want to sum 80 terms for this pattern. And so what summation notation does is you have your starting n here, like your starting position. Up top, you put the ending position or the ending n. And then here you just write, this is the formula used to generate these numbers, the 4, 8, 12, 16, 20, 24, 28. So this is what we call the explicit formula. Okay, so knowing that, see if you can pause the video and figure out summation notation for that series. All right, so our answer here is we're going to sum from position 1 to 80. We start at 1 and we go up to 80, even though we don't know what the last term is. That's how far we're going. Okay, and then we just got to do the explicit formula. So we've done this a bunch already in this video. So this is an arithmetic one. So it's a1 plus dn minus 1. So a1 is 4. D is also 4 because we're going up by 4 each time. And then if we clean it up, distribute that 4. So we have 4 plus 4n minus 4. And then the positive 4, negative 4, so we just end up with 4n. So our explicit formula is an equals 4n. And that's what we put right here. We just put the 4n part. So basically, this E represents that sum, right? So if we just had the E, we could generate the sum by putting in 1 for n, that would get us the 4, then put in 2, that would get us the 8, put in 3, that would get us the 12, and we do that all the way up to n of 80. So we can sort of see that this whole thing is represented by that E, right? It's just another way to write a sum of terms kind of in a condensed form, right? And that's what summation notation is. All right, so let's try one more. Write it in big E notation and then actually find the sum. Okay, so I'm going to write my big E. So pause the video, give it a shot. Okay, so we know that we have 10 terms. So we're going to go from position 1 to position 10. And my explicit formula would be, let's see, it would be A1 plus, what are we going up by there? 8, I think. Yeah, plus 8n minus 1. So if we clean that up, we have 57 plus 8n minus 8, distribute, and add those together. So that's 49 plus 8n, negative 8, and 57. Okay, and so we want to actually find the sum. So we are adding all these up, and this is an arithmetic pattern. So the arithmetic sum goes again, the number of terms divided by 2, first term plus last term. So we know this time the number of terms is 10. They tell us that right in the question. We also can see it up here. Okay, we know the first value is 57, but what we don't know is the last term, an. Okay, but luckily, right down here, we already wrote our explicit formula. It was just 49 plus 8n. So the last term in our sum is the 10th spot. So we can just do, okay, a sub 10 is just 49 plus 8 times 10. So we have 49 plus 80, and that's going to give us 129. So that's going to be the last part of this formula, which I'm going to have a hard time fitting in right there. Okay, and now just crunch all this on the formula. So it's going to be 5 times some number in there to get your total. To be 5 times 186 when you add those together, so 702. final answer.